Good evening all of you. Today we will be doing using induction prove that 1 cube, 2 cube, 3 cube and so on till n cube equals n square n plus 1 whole square whole upon 4. Now the very first thing to be done, let Pn be the given relation. So we have assumed this relation to be Pn. Now after this, because the first step of induction, that is a basic step of induction, is to check the given relation for n equal to 1. So in place of n, we write n, put n equal to 1. So LHS, putting n equal to 1 means the very first term, which is 1 cube, which will give us 1. Then RHS. RHS is, in place of n we will write 1. So this will be 1 square into 1 plus 1 of whole square whole upon 4. So this will be 1 into 4 whole upon 4, which is again equal to 1. So we get LHS is equal to RHS. Therefore, P1 is true. Now the second step of induction. The second is the assumption step. That is, we assume the relation to be true for n equal to k. So we'll write let P of k be true. If we assume P of k to be true, this relation will become 1 cube, 2 cube and so on till k cube is equal to k square, k plus 1 of whole square whole upon 4, and we'll assume that this is equation 1. Now, the most important step of induction, the third step. The third step is the proving step. That is, by the help of this equation, by the help of P of k, we need to prove it true for n equal to k plus 1. So now this is a proving step. Put n equals k plus 1 in Pn. Now because this is a proving step, so again we need to solve LHS and RHS separately. LHS will be, that is, wherever there is n, in place of that we will write k plus 1. So this will be 1 cube, 2 cube, 3 cube and so on till k plus 1 of whole cube. Now clearly the predecessor of k plus 1, that is the previous term, the preceding term is k, so it will become k cube. Now as you can notice, in place of this complete, we can utilize equation 1. So this is k square, k plus 1 of whole square whole divided by 4 and plus k plus 1 of whole cube. Now through this we can take k plus 1 of whole square as common. What will be left? K square upon 4 plus k plus 1. This will be left. After taking LCM, this will become k plus 1 of whole square, k square plus 4k plus 4 whole upon 4. As you can notice, you can clearly write this as k plus 1 of whole square, k plus 2 of whole square, because this is a square plus b square plus 2ab. So this will be k plus 2 of whole square whole divided by 4. So LHS has been completely solved. Now we'll start with RHS. The same substitution is to be put in RHS. As you can see, in place of n we have written k plus 1 in LHS. So in RHS also we will do the same thing. In place of n, k plus 1. So this will become k plus 1 of whole square. Here in place of n, if we write k plus 1, it will be k plus 1 plus 1, which will give us k plus 2 of whole square and whole divided by 4. LHS was k plus 1 of whole square, k plus 2 of whole square whole upon 4. The same thing goes for RHS. So we can easily conclude that LHS is equal to RHS and therefore P of k plus 1 is true. Now because P of k plus 1 is true, that is, we have checked it for n equal to 1, we assumed it for n equal to k, and then by the help of this equation we have proved it for n equal to k plus 1. So therefore we can write Pn is true for all n belonging to k. So this is how the questions of induction are to be solved. Thank you.